Over the past 24 to 48 hours, a set of photographs has begun circulating through private astronomy forums that should not exist. Not in the way they appear, not with what they're allegedly showing. Images that, if authentic, render every official explanation about 3I Atlas fundamentally incomplete. And here is the thing that is going to keep you up tonight. NASA isn't saying a word about them. Let me be very direct with you. You are watching this video at a specific moment in history. Right now, as you sit there, an interstellar object that originated outside our solar system is passing through our solar system at a reasonably close distance in astronomical terms. It is visible. It is being photographed, and the images coming back are creating a quiet crisis in astronomy communities that mainstream media has completely ignored. How is that even possible? How does something this significant, this immediate, this observable, remain buried in forum discussions and private channels while your evening news talks about everything except this? I need you to understand something before we go any further. This isn't speculation about distant possibilities. This isn't a conspiracy theory built on absence of evidence. What we're discussing today is happening right now above your head, observable through telescopes, documented by multiple sources, and creating genuine confusion among credentialed scientists who are seeing data that conflicts with official narratives. The photographs we're going to examine, these leaked images that appeared online just days ago, they're not decades old, grainy artifacts. They're current, recent, and they're raising questions that official channels seem deeply uncomfortable addressing. Here is what makes this extraordinary. When these images started appearing on Reddit, X posts, and on specialized astronomy forums, in private Discord channels frequented by amateur astronomers and professional researchers alike, the response wasn't dismissal. It was a debate. Serious, technical, detailed debate about what these photographs actually show, and then almost immediately a kind of silence descended. Not the silence of debunking, but the silence of uncertainty. The kind of quiet that happens when people who know what they're looking at see something that doesn't fit existing frameworks. Everything about 3I Atlas has been unusual from the beginning. The way it was detected, the observations that followed, the color changes documented by multiple observatories, the unexpected brightness fluctuations that confused scientists on record, the water signatures detected in ways that raised eyebrows. All of this is verified, documented, published in scientific literature. That is not disputed. What is disputed is what it means. And now these photographs enter that context. Images allegedly captured during recent observation windows circulating with claims about structural features, about surface characteristics, about details that shouldn't be visible on what we're told is a fragmenting comet covered in dust and gas. Online communities are analyzing pixel data. People are comparing these images with verified photographs from established observatories. And the conversations happening in these spaces aren't fringe conspiracy discussions. They're technical analyses involving people who understand orbital mechanics, spectral analysis, photographic enhancement techniques, and cometary physics. Here is the thing, and this is why I need you to hit that like button right now before you forget. Because this matters, these images are circulating in spaces where actual scientists participate. They're being discussed by people with credentials, with access to professional equipment, with reputations to protect. Yet, your mainstream news, complete silence. CNN isn't covering this. BBC isn't investigating this. The major science publications that should be either confirming or debunking these images, they're not touching it. That silence itself is a form of information. When something is obviously fake, debunking is swift and definitive. When something is complicated, when something might challenge accepted narratives, when something requires investigation that might lead to uncomfortable questions, that is when you get silence. If you are the type of person who wants to see what they're not showing you, what they're actively avoiding, then stick around. Drop a comment telling me where you are watching from, because I want to know if you are seeing these observations too. Because in the next 15 minutes, we're going to examine something that challenges everything official sources have told us. We're going to look at the documented anomalies that preceded these photographs. We're going to examine what credible scientists have said on record about observations that don't fit standard cometary behavior. And then we'll get to the photographs themselves, the claims being made about them, and why the response from official channels is itself revealing. Tell me something. When was the last time you encountered information that genuinely surprised you? Not entertainment surprised, not plot twist surprised, but intellectually challenged in a way that made you question what you thought you understood. That is what is happening in astronomy circles right now. People who study comets professionally, who understand the physics, who know what should happen when an interstellar object passes through our solar systems, They're seeing things that don't align with predictions. And some of those things are captured in these leaked photographs. I want to be completely transparent with you about what we're doing here. This isn't a video claiming definitive answers. This is an investigation into questions that aren't being asked publicly. We're going to examine what is being claimed, what evidence supports or contradicts those claims, and why the larger scientific establishment seems reluctant to engage with any of it. You are going to see the data, you are going to hear what credible researchers have said, and you are going to encounter the photographs that are causing quiet confusion in communities that deal with this subject matter professionally. One more thing before we dive in. November 2025 is the observation window right now. This month, 3i Atlas becomes visible again in the pre-dawn sky on November 11th. Its closest approach to Earth happens on December 19th. If you have access to a telescope with decent aperture, you can observe this yourself. You can take your own photographs. You can compare what you capture with what is being discussed online. This isn't ancient history we're debating. This is present tense observable reality. And that is what makes the silence so conspicuous. When something is happening now, visible now, documentable now, and major media outlets aren't touching it, you have to ask yourself why. What makes this topic radioactive? What makes these questions dangerous? What about these photographs, these observations? These discussions happening in specialized communities has created this vacuum of mainstream coverage. That is what we're here to explore. Not to give you answers wrapped in certainty, but to examine questions wrapped in credible uncertainty. So, let's begin where this story takes its most interesting turn, not at the discovery of 3i Atlas itself, because you probably already know that story, but at the observations that followed, the anomalies that accumulated, and the pattern of official responses that set the stage for why these leaked photographs matter at all. You already know 3i Atlas didn't originate in our solar system. You probably know it was detected earlier this year that it is the third confirmed interstellar object we've identified, that it is currently making its way through our cosmic neighborhood on a trajectory that brings it closer to Earth than any previous interstellar visitor. That is the basic story. But what you might not know, what doesn't make it into the headline summaries, is that from the very beginning, from those first detection moments, something was off. Not dramatically off, not obviously wrong, just inconsistent. Small details that didn't quite match expectations, observations that required explanations slightly more complicated than they should have been, the kind of discrepancies that scientists notice, discuss in technical papers, and then move past with amended models. Except this time, the discrepancies kept accumulating. Each new observation added another small question mark. Each attempt to explain one anomaly seemed to reveal another. Let me give you context for why this matters. When you detect an interstellar object, you are working with predictions based on models we've developed from observing thousands of comets and asteroids native to our solar system. We know what comets do. We understand their behavior patterns. We can predict how they'll brighten as they approach the sun, how they'll develop tails, what their spectral signatures should reveal about composition. These aren't wild guesses. They're frameworks built on decades of observation and data. So when an object behaves differently than those frameworks predict, it is noteworthy. When multiple observations show unexpected characteristics, it is puzzling. When those puzzles persist across different observatories using different detection methods, it becomes a legitimate scientific question. 3i Atlas accumulated those puzzles faster than explanations could comfortably account for them. Early observations showed color characteristics that didn't match standard cometary composition models. Not wildly different, just enough to require adjusted explanations. Then came brightness measurements that fluctuated in ways that suggested either an unusual rotation pattern or something about the object's surface properties that didn't fit typical comet profiles. Again, explainable with modifications to assumptions, but requiring those modifications in the first place. Here is where it gets interesting. By late summer 2025, multiple observatories were tracking 3i Atlas as it approached perihelion, its closest point to the Sun. This is when comets typically become most active. Solar radiation heats the surface, sublimates ice into gas, creates the brilliant tails we associate with cometary displays. We had predictions for how bright 3i Atlas should become based on its size, composition estimates, and orbital trajectory. Those predictions were based on solid physics, and they were wrong. On October 31st, just days ago, 3i Atlas exhibited an unexpected brightening event that wasn't supposed to happen. Not a dramatic explosive brightening, but a measurable increase that didn't correspond with where it was in its orbit or what solar radiation intensity it was experiencing. Scientists on record describe this as confusing. That is a careful word in scientific literature. Confusing means we don't have a comfortable explanation that fits our models. But the brightness anomaly wasn't isolated. Around the same time, observations from the Neil Gehrels Swift Observatory detected hydroxyl gas signatures, essentially the fingerprint of water molecules being broken apart by solar radiation. Now, finding water signatures around a comet isn't shocking. Comets contain ice. Ice sublimates near the sun. Water vapor appears routine, except the amount and distribution pattern of these hydroxyl signatures didn't quite match what the object's size and distance from the sun should have produced. It was more than expected, present in ways that suggested either the object contained more volatile materials than initial composition estimates indicated, or something about how those materials were being released wasn't following standard sublimation patterns. Then came the color changes. Not speculation, documented color changes. By early November, observers noted that 3I Atlas had developed a faint bluish hue that hadn't been present in earlier observations. This marked the third distinct color shift since detection. Each change corresponded loosely with different phases of its approach and passage around the sun, but the sequence and characteristics of these color transitions didn't precisely match any known cometary behavior pattern. They were close, similar enough to explain as variation, but distinct enough that papers examining the object kept noting these characteristics as unusual. You see the pattern forming here. No single observation is inexplicable. Each anomaly has a possible natural explanation. But the accumulation, the consistent pattern of observations requiring explanation of data points that sit just outside predicted parameters, that accumulation creates what I call documented mystery. It is not conspiracy. It is not wild speculation. It is the scientific record showing an object that persistently refuses to behave exactly as models predict it should. And here is what makes this context crucial for understanding the leaked photographs. By the time these images started circulating in early November, the astronomical community was already in a state of heightened attention regarding 3I Atlas. This wasn't some random object receiving routine observation. This was an interstellar visitor exhibiting unusual characteristics that multiple professional observatories had documented. Credible scientists were already discussing the object's atypical behavior in published research and conference presentations. The question wasn't whether 3I Atlas was behaving normally. It clearly wasn't by strict standards. The question was whether its unusual characteristics represented natural variation within cometary behavior, or something more fundamentally different. That is the atmosphere into which these photographs emerged, not into a vacuum of ignorance, but into an ongoing scientific discussion about an object that was already raising legitimate questions. And that context matters enormously for how we evaluate the images and the claims surrounding them. There is something else you need to understand about the timeline here. Early November 2025 marks the period when 3I Atlas became optically observable again after its perihelion passage. For several weeks, it had been too close to the sun's position in our sky for effective observation from Earth. The brightness of the sun overwhelmed any ability to capture detailed images. But as it moved away from that alignment, observation windows opened. This is when multiple observatories, both professional and amateur, began capturing new images of the object post-perihelion. And this is when the leaked photographs allegedly originated. Images supposedly captured during these early November observation sessions processed through standard astronomical imaging techniques and then shared in online communities where people analyze this kind of data. The claims emerging around these images didn't appear in isolation. They appeared in the context of months of documented anomalies. Scientific papers noting unusual characteristics and an astronomical community already puzzled by what they were observing. So when we talk about leaked NASA photos, we're not talking about images that suddenly appeared from nowhere making wild claims about an otherwise normal object. We're talking about photographs that entered circulation during a period when the object's behavior was already documented as atypical, when scientific interest was already elevated, when observation conditions had just improved enough to capture detailed imagery. That context transforms how we evaluate both the images themselves and the response or non-response from official sources. Let me show you something most coverage completely glosses over. Pull up any mainstream article about 3I Atlas, and you'll get the basic narrative. Interstellar comet passing through our solar system, scientists observing it. Interesting, but routine. What you won't get is the actual observational data that makes this object genuinely anomalous. Not anomalous in a sensational way that screams headlines, but anomalous in a persistent, documented, scientifically acknowledged way that raises questions no one seems eager to answer publicly. Start with those color changes I mentioned. This isn't subjective interpretation. Multiple observatories recorded spectral data showing distinct shifts in the object's color profile over time. The first shift occurred during its initial approach when the object transitioned from a relatively neutral color to a distinctly reddish hue. This corresponds with what we'd expect from a carbon-rich surface being exposed to solar radiation, standard cometary behavior. But then as it continued its approach toward perihelion, the color shifted again, this time toward a more neutral, almost grayish appearance. That is unusual. Comets typically get redder as organic compounds on their surface are processed by radiation, not grayer. The third shift, that bluish hue developing in early November, that is where explanations start getting creative. Blue coloring in comets typically indicates specific chemical compositions or dust grain sizes that scatter light in particular ways. But for that blue tint to appear after perihelion passage, after the object had already been subjected to intense solar radiation, after two previous color shifts had occurred, that sequence doesn't fit any standard cometary evolution model cleanly. It is explicable, but it requires assuming specific compositional characteristics and surface processes that we have no independent confirmation of. We're making the explanation fit the observation rather than the observation confirming our predictions. Now, layer the brightness behavior onto that. The October 30th unexpected brightening wasn't an isolated incident. It was the most dramatic in a series of brightness fluctuations that had been puzzling observers for weeks. Comets brighten and dim based largely on their distance from the Sun and their level of activity. How much material is sublimating off the surface? You can predict brightness curves with reasonable accuracy if you know the comet's size and composition. 3I Atlas kept deviating from those predictions, sometimes brighter than expected, sometimes dimmer, following a pattern that suggested either the object was rotating in a highly unusual manner, exposing surfaces with dramatically different reflective properties, or its activity level was fluctuating in ways that don't match standard models of cometary outgassing. Scientists tried to account for this by proposing that the object might be fragmenting, that chunks were breaking off, temporarily increasing brightness as fresh surface material was exposed. Fragmentation is common for comets under solar stress. Perfectly reasonable explanation, except observations specifically looking for evidence of fragmentation debris fields, secondary objects, expanding dust clouds, characteristic of breakup events, didn't find clear confirmation. The object appeared to remain relatively intact, so you had brightness behavior suggesting fragmentation, but imagery suggesting cohesion. Another puzzle requiring another creative explanation. Then there is that water signature data from the Neil Gehrels Swift Observatory. On November 2nd, the observatory detected hydroxyl emissions indicating water was present and being released from the object. But here is the specific detail that matters. The amount and distribution pattern suggested the water wasn't coming uniformly from the surface, as you'd expect from standard ice sublimation. The emission pattern was more concentrated, almost directional. Some observers noted this could indicate water was being released from specific active areas on the surface rather than from general sublimation across the entire object. That happens with comets. Sometimes they develop active jets from particular locations, but the pattern of hydroxyl emission from 3I Atlas was more pronounced than typical jet behavior. It looked almost like water was being expelled from specific points rather than sublimating from surface ice. I want to pause here and emphasize something crucial. Every single detail I just described is documented in scientific observation records. These aren't rumors. These aren't online speculation. These are published findings from credible observatories using standard detection methods. Scientists are on record noting these characteristics and expressing puzzlement about them. The mainstream science establishment isn't denying any of this. They're just not emphasizing it. It gets mentioned in technical papers, discussed at conferences, noted in observation reports, but it doesn't make it into public science communication. NASA's public updates about 3I Atlas present it as a straightforward interstellar comet. The complications, the anomalies, the unexplained characteristics, those stay buried in technical literature that general audiences never encounter. Here is another observation that barely got attention. The European Space Agency's ESA instruments tracked 3I Atlas during its close approach to Mars in September. Mars doesn't have Earth's atmosphere to interfere with observations, and ESA instruments had a unique viewing angle during that time frame. They captured spectral data that showed inconsistencies. The composition signatures weren't matching initial estimates from earlier observations. Elements that should have been present weren't showing strong signatures, Elements that shouldn't have been prominent were: the official explanation was that the object's composition was more heterogeneous than initially thought. Different areas had different makeups. Again, reasonable explanation. Also, again, explanation created to fit unexpected observation rather than observation confirming prediction. Some Japanese amateur observers noted that in late October, 3I Atlas exhibited what they described as irregular coma development. The coma, the cloud of gas and dust surrounding a comet's nucleus, typically develops in predictable patterns as the comet heats up. 3I Atlas developed a coma that seemed to expand and contract in ways that didn't correlate cleanly with its distance from the Sun or predicted activity levels. Some days it appeared more active than it should have been, other days less active. The pattern didn't match solar radiation intensity or any obvious trigger. It was just irregular. One more detail that is going to become important when we discuss the leaked photographs. In late September, the Gemini South Telescope in Chile captured what are still considered some of the best verified images of 3I Atlas. These images showed clear coma and tail development, documented the object's visual characteristics at high resolution, and provided a baseline for what the object looked like during that observation window. These are the images scientists reference when discussing the object's appearance. Clear, verified, published, accepted. When we get to the leaked photographs from November, keep these September images in mind because the comparison between verified September imagery and alleged November imagery is where things get genuinely strange. Notice what I am doing here. I am not leading with sensational claims. I am building a foundation of documented scientific observation that establishes this object has been consistently unusual across multiple independent detection methods, across multiple observatories, across multiple observation windows. This isn't about any single shocking revelation. It is about a pattern of data that persistently refuses to align perfectly with our predictive models. Each anomaly is small, but small anomalies accumulate into legitimate scientific mystery. And that accumulation is what makes the leaked photographs significant. They didn't appear in a vacuum claiming something wild about an otherwise normal object. They appeared in the context of months of documented unusual behavior into a scientific community already puzzled by observations that required creative explanation during a crucial observation window when new detailed imagery was becoming possible. The photographs are one more data point in a larger pattern of this object not quite behaving as expected. Whether they're authentic, whether the claims about them are accurate, whether they reveal what observers say they reveal, that is what we need to examine next. So, here is where the story shifts from documented scientific anomalies to something more contentious, more uncertain, and significantly more controversial. Starting around November 3, 2025, just 2 days ago, images began appearing in online astronomy communities claiming to show detailed views of 3I Atlas captured during recent observation windows. Not official NASA releases, not peer-reviewed publications, but photographs circulating through Reddit astronomy forums, through Discord servers where amateur astronomers share observations, through specialized image sharing platforms used by people who process astrophotography data. The first thing you need to understand is how these images allegedly originated. According to the post accompanying them, they were captured by multiple independent observers using various telescopes during early November observation sessions when 3I Atlas became visible, again post-perihelion. Some claim to be amateur astronomers with serious equipment. We're talking 10-inch to 16-inch telescopes with professional-grade cameras and imaging software. Others claim the images came from smaller observatory networks that share data publicly, but don't necessarily get mainstream attention. A few posts suggested the images were processed versions of data from larger observatories that someone had accessed and enhanced. Now, immediately we're in uncertain territory. These aren't images with clear verified chains of custody. They're not published with full metadata showing exactly when, where, and how they were captured. They're essentially anonymous contributions to online discussions uploaded by users with varying levels of credibility, accompanied by claims that may or may not be accurate. This is important context. I am not presenting these as verified NASA photographs that leaked from official channels. I am telling you that images claiming to show specific details about 3I Atlas are circulating in communities where people analyze astronomical data, and those images are generating significant discussion and debate. What do these images allegedly show? This is where it gets specific and where I need to be very careful about framing. Multiple versions of these images exist, processed in different ways by different people, but the consistent claims across various posts focus on a few key observations. First, that when properly processed and enhanced standard techniques in astrophotography to bring out detail, the images appear to show surface structure that is unusually distinct for an object at 3i atlases distance. We're talking about an object over 268.9 million kilometers, 1.797 astronomical units away at closest approach. At that distance, even with good telescopes, you typically get a fuzzy blob, maybe some detail in the coma, but not clear surface features. These images, as posted, appear to show geometric patterns. Not dramatically. This isn't like looking at a photograph of a spacecraft with obvious engineered features. It is subtle, but observers are claiming that certain areas show regular patterns, edges that seem too straight, symmetries that seem unlikely for a natural fragmented rock covered in sublimating ice and dust. The specific claim isn't "this looks like a machine." The specific claim is "this shows structural features that are difficult to explain as random fragmentation or natural geological processes." The second major claim involves what is being described as dust coverage patterns. When you look at an active comet, you are seeing it through a haze of dust and gas that it is actively releasing. That haze should obscure surface details, create a fuzzy appearance, make it impossible to see clear structure underneath. But these images allegedly show areas where the dust coverage appears uneven, spots where surface detail is more visible, as if whatever is underneath is either not releasing material uniformly, or is somehow visible through the coma in ways that shouldn't be possible given standard cometary physics. Third, there are claims about brightness consistency in several of the circulating images. Observers note that certain features maintain consistent brightness relative to each other across different images captured at different times. If you are looking at a tumbling, fragmenting, outgassing comet, you'd expect brightness patterns to shift as different surfaces rotate into view, as dust distribution changes as activity levels fluctuate. But the claim is that specific features visible in these images maintain similar relative brightness and position, suggesting either very slow rotation, structural stability, or surface characteristics that remain consistent despite ongoing solar radiation exposure. Now, here is where we enter serious evaluation territory. How do we assess these claims? First, we look at the discussion happening around the images. When something is obviously fake in astronomical photography, experienced observers identify it quickly. They analyze pixel data. They check for artifacts from processing. They compare with known imagery from the same time period using verified equipment. The conversation around these 3i Atlas images isn't immediate dismissal. It is debate. Some observers are arguing the features are artifacts of image processing, that when you enhance astronomical images to bring out faint detail, you can create the appearance of structure that isn't really there. Others are arguing they've processed similar data independently and are seeing similar features. Some are claiming they've observed 3i Atlas themselves with comparable equipment and their images don't show these features. Others say their images do show unusual characteristics, but they're not sure how to interpret them. In the 24 to 36 hours, roughly November 4th, 5th, reports circulating in Japanese astronomy communities on November 4th noted that recent imaging of 3i Atlas showed what they described as unexpected visual characteristics that didn't match previous observation data from September. They specifically mentioned that the object's appearance had changed in ways that weren't fully explained by predictable changes in viewing angle, distance, or activity level. They didn't post the dramatic images circulating on Reddit, but they did acknowledge seeing something unexpected that required further investigation. This is what makes the situation complicated. You have unofficial images making specific claims circulating online. You have official observation organizations noting unexpected characteristics without providing detailed imagery. You have amateur astronomers saying they see unusual features. You have other amateur astronomers saying they don't. You have processing experts debating whether the details in enhanced images are real or artifacts. And through all of this, you have complete silence from the major institutional players, NASA, ESA, major observatories, about any of this discussion. That silence is perhaps the most fascinating element. When clearly fake astronomical images circulate online, institutions typically respond quickly with debunking statements. When something legitimate but misunderstood is circulating, they clarify with educational posts. When the images circulating are genuine but being misinterpreted, they provide context. Here, with these 3i Atlas images generating substantial discussion in astronomy communities, some of which include professional researchers, there is no response at all. No confirmation, no debunking, no clarification, just absence. Let me be absolutely clear about what I am presenting here. These are unverified images, making specific claims, circulating in online communities, generating debate among people with varying levels of expertise. I am not telling you these are authentic NASA photographs that leaked from classified channels. I am not telling you these images definitively show what observers claim they show. What I am telling you is that during a crucial observation window for an object that has already exhibited documented anomalies, images are circulating that are generating serious technical discussion, and the institutional response to that discussion is complete silence. The story isn't necessarily the images themselves. The story is the pattern. Unusual object behavior documented by official sources, observation window opening that allows detailed imaging, images appearing that claim to show unexpected features, technical community debating those images, seriously official sources completely ignoring the discussion. You see why context matters. If these images had appeared 6 months ago making wild claims about 3i Atlas when official observations showed completely normal behavior, the entire discussion would be different. But they appeared after months of documented anomalies during a window when new detailed observations were becoming possible into a community already discussing the object's unusual characteristics. They're not creating a mystery, they're adding a layer to an existing one. And that existing mystery, that foundation of documented scientific puzzlement, is what we need to examine more closely. Because whether these specific images are authentic or not, whether the features observers claim to see are real or artifacts, the underlying question remains: why has this object consistently behaved in ways that require explanation? Why has every observation session revealed characteristics that don't quite match predictions? And why, when images circulating online claim to show structural anomalies, is the response from official channels not clarification, but silence? Let's get technical, because this is where casual dismissal becomes more difficult. When you examine the specific claims being made about these images, when you dig into what observers are actually saying, they're seeing rather than accepting superficial summaries, you encounter details that demand either serious debunking or serious investigation, neither of which is happening publicly from official sources. Start with the geometric observations. I need you to understand what is actually being claimed here, because it is more specific and more measured than "this looks artificial." The claim is that certain features visible in enhanced images show patterns of regularity that are statistically unlikely in natural fragmented objects. Let me explain what that means. When you look at asteroids, comets, or any natural space rock, you see irregular shapes, crags, bumps, random features created by impacts, by gravitational stresses, by uneven material composition. There is no regularity because there is no process creating regularity. It is chaos shaped by physics. What several analysts examining these 3i Atlas images are noting is that certain edge features appear to show consistent angles. Not perfect right angles, nothing that obvious, but edge alignments that recur at similar degrees, length ratios that appear proportional, symmetries that seem statistically improbable. The specific analysis some are doing involves measuring pixel distances, calculating angles, comparing features across multiple images captured from slightly different viewing angles. And what they're finding, what they claim to be finding, is consistency that natural fragmentation shouldn't produce. Now, the counterargument is straightforward. This is practical imaging. You are looking at a fuzzy image of a distant object. You are applying enhancement algorithms that can create artificial patterns, and your brain is finding structure in noise. That is a completely reasonable explanation. That is probably the correct explanation, except for one complicating factor. Multiple independent observers processing different datasets are claiming to see similar patterns. When pareidolia occurs, it is typically individual. One person sees a face in a cloud pattern that others don't. When multiple people processing different versions of data through different software are identifying similar angular relationships and proportional measurements, that is either coordinated misinterpretation, or there is something in the source data generating that consistency. Then there is the dust coverage issue, which is actually more interesting from a physics perspective. Active comets are surrounded by their own coma, the cloud of dust and gas they're actively shedding. That coma should obscure surface details, especially for an object at 3i Atlas's distance, where you are already working at the limits of telescopic resolution. You shouldn't be able to see clear surface structure through an active coma. Yet, the images circulating appear to show exactly that. Some areas appear to have clear defined edges visible, despite being surrounded by the fuzzy glow of coma material. The explanation observers are proposing is that the dust release is non-uniform, that 3i Atlas is shedding material, primarily from certain areas while other areas remain relatively inactive, allowing those inactive zones to be more clearly visible. That is possible. Comets do have active regions, but typically even inactive areas get obscured by dust from active regions spreading around the entire object. The claim here is that you are seeing persistent clarity in specific areas across multiple images, suggesting either remarkably localized dust release or surface properties in those clear areas that somehow prevent dust accumulation or scattering in ways that would obscure them. Consider what that would require physically. For surface areas to remain clearly visible through an active coma, you'd need either 1. Those areas to be releasing absolutely no material themselves despite being subjected to the same solar radiation as active areas. 2. The material they are releasing to be fundamentally different, in ways that don't create optical obscuration. Or 3. Some mechanism by which dust from active areas is being prevented from settling on or obscuring these zones. None of those explanations fit standard cometary physics cleanly. Comets don't have mechanisms to prevent dust migration. They don't have surface zones that remain completely inactive while adjacent areas outgas vigorously. And their composition is generally uniform enough that all areas should behave similarly under equivalent solar radiation. Now, let's discuss the brightness consistency claim because this gets into rotational dynamics. If you are observing a tumbling object over multiple days or weeks, you expect to see brightness variations as different surfaces rotate into and out of sunlight, as different areas face toward or away from your viewing angle. That brightness variation is actually how we determine rotation periods for asteroids and comets. We measure how brightness changes over time and calculate how fast the object must be spinning to produce that light curve. What is being claimed about these 3i Atlas images is that specific features maintain similar relative brightness and position across multiple observation sessions. If true, that suggests one of 3 possibilities. The object is rotating very slowly, which would be unusual for a small body that should have been set spinning by asymmetric outgassing forces. The object is rotating in a very stable manner on an axis aligned with our viewing angle, which would be a remarkable coincidence. Or the features we're seeing are so large scale or so inherent to the object's structure that they remain visible regardless of rotation. None of those are impossible. All of them are improbable enough to warrant explanation. Here is where I need to bring in the comparative analysis because this matters. We have verified images of 3i Atlas from late September captured by the Gemini South Telescope, professional equipment, verified processing published data. Those images show a clear comet-like appearance. Fuzzy coma, developing tail, no obvious surface structure, standard presentation. Now, if the November images circulating online are authentic and showing what observers claim, that means the object's appearance changed dramatically between late September and early November. That is a roughly 5-week span during which it passed perihelion, its closest approach to the Sun, and experienced maximum solar radiation intensity. Cooled perihelion passage, change a comet's appearance enough to explain the difference between September and November imagery? Absolutely. Perihelion is when things get violent for comets. Material sublimates rapidly. Surface layers can be stripped away. Fragmentation often occurs. An object could legitimately look different post-perihelion. But typically those changes make comets look more diffuse, more active, more fuzzy, not less. Perihelion passage should increase coma density, should increase dust production, should make surface features harder to see, not easier yet. The claim about these November images is that they show more defined structure, clearer features, less obscuration. That is backwards from what perihelion passage should produce. The alternative explanation some observers are offering is that perihelion stripped away surface layers, exposing underlying structure that was previously covered by volatile, rich material. Think of it like ice coating melting off an object underneath, revealing what is beneath. That is conceivable, but it would require the underlying structure to be significantly different in composition from the surface layers, different enough not to sublimate significantly itself, despite direct solar exposure. You'd need something like a rocky core covered in ice where the ice sublimates, but the rock remains intact and visible. That is possible for a comet. It is just not what we typically observe because most cometary nuclei are relatively uniform mixtures of ice and rock that sublimate roughly together. Let me introduce one more technical detail that several analysts have noted. In astronomical imaging, you can analyze edge sharpness through something called point spread function, PSF, analysis. Basically, you measure how sharply defined edges appear in an image, which tells you whether you are looking at real features or optical artifacts. Several people examining these 3i Atlas images claim that certain edges have PSF characteristics consistent with real physical boundaries rather than processing artifacts or optical diffraction effects. I can't verify those analyses personally. I am not an expert in photometric image analysis, but the people making these claims are posting their methodologies and measurements publicly, inviting others to verify or refute their findings, and the response they're getting isn't "you are obviously wrong." It is continued debate about interpretation. You see the complexity emerging here. This isn't a simple case of obvious fake images or clear authentic images. This is genuinely ambiguous data being interpreted differently by people with different levels of expertise and different base assumptions. Some see artifacts, some see real features, some see interesting data requiring investigation, some see nothing unusual at all. And through all this technical debate happening in public forums, in image analysis threads, in astronomy Discord channels where people are literally processing data sets and comparing results, through all of that NASA says nothing, ESA says nothing, major observatories say nothing. Why does that matter? Because if these images are obviously fake or obviously misinterpreted, saying so is easy. Posting verified comparison images from the same observation windows is straightforward, providing clear technical explanation for why the features observers think they're seeing are actually processing artifacts or optical illusions. That is standard science communication. The absence of that response is itself strange. It suggests either the images and claims are being deemed not worth responding to, or they're complicated enough that responding requires more careful consideration than a quick debunking statement can provide. And that brings us to the most important question. What would it mean if these observations have any validity? Not full validity. Not taking every claim at face value, but if even the core observation is partially accurate, that enhanced imagery from November shows more structural definition than September imagery, that some features maintain consistency across multiple observation sessions, that dust distribution appears unusually non-uniform. If those basic observations are real, what does that tell us about 3i Atlas? This is where we move from observation into interpretation territory, and I need to be very careful about how we navigate this, because the stakes of these questions are substantial. Let's establish a framework for thinking about what these accumulated anomalies might mean, from the conservative explanations to the more speculative possibilities, while maintaining clear distinctions between what is documented and what is interpretation. Start with the most conservative explanation. Everything we're seeing, all the brightness fluctuations, the color changes, the unexpected observations, the features in enhanced imagery, all of it is natural cometary behavior, just unusual natural behavior. Comets are diverse. Every comet is slightly different. 3i Atlas is an interstellar comet, meaning it formed in a different stellar system under different conditions. So, expecting it to behave exactly like our solar system's comets is unreasonable. The anomalies we're documenting are natural variation, and our models are incomplete because we haven't observed enough interstellar objects to know the full range of their possible characteristics. Under this framework, enhanced images showing structural features are seeing fragmentation patterns, exposed subsurface layers, irregular material composition, all natural, all explicable, just unfamiliar. That is not only plausible, it is likely the correct explanation. Science operates on parsimony. Prefer the explanation that requires the fewest unsupported assumptions. Natural unusual behavior requires fewer assumptions than any alternative. The problem is this explanation requires accepting an awful lot of coincidental unusual behavior. The object is unusual in its color evolution, and unusual in its brightness variations, and unusual in its water emission patterns, and unusual in its coma development, and unusual in showing structural features through that coma. Each individual anomaly fits within unusual, but natural. But the accumulation of unusual characteristics in a single object starts straining coincidence. The next explanatory level involves composition. Perhaps 3i Atlas isn't primarily ice and rock like typical comets, but has a significantly different composition ratio that produces its unusual behavior. Maybe it is more rocky than icy, which would explain why it is not fragmenting dramatically, why dust release is non-uniform, why it is maintaining structural integrity through perihelion passage. Some asteroids masquerade as comets when they get close enough to the Sun to release trapped volatiles. Maybe 3i Atlas is essentially an interstellar asteroid with an ice coating rather than a true comet. That would explain observations pretty well. The color changes would be surface processing. The structural visibility would be seeing a solid object beneath a thin, volatile layer. The brightness behavior would reflect a more stable rocky surface rather than active ice sublimation. This explanation handles most anomalies reasonably, but it creates new questions. If 3I Atlas is primarily rocky, where did the water signatures come from? Rocky asteroids can contain ice in pockets or subsurface layers, and that ice can outgas. But the hydroxyl emissions detected suggested significant water release. You'd need substantial ice reservoirs in what is supposed to be a primarily rocky object. Possible, just compositionally unusual. Also, this explanation doesn't address why enhanced imagery shows features with geometric regularity or unusual symmetry. If anything, rocky asteroids tend to be even more irregularly shaped than icy comets because they fracture along stress lines without the smoothing effect of sublimation. Now, we enter more speculative territory, and this is where I need to be explicit about what we're doing. We're moving from documented observation and conventional explanation into what if the conventional explanations are insufficient territory. This isn't claiming answers. This is examining questions that emerge if standard frameworks don't fully account for observations. One possibility: 3I Atlas could be a fragment of a larger body that was disrupted by gravitational or impact forces before entering our solar system. Imagine a small planet or a large asteroid that was shattered, and what we're seeing is a chunk of that destroyed world. If that chunk includes both surface materials and deeper structural layers, maybe even interior materials from the parent body, you could get the unusual composition mix we're observing. Surface layers that sublimate and create comet-like behavior, but underlying structure that remains intact and potentially visible. This would explain compositional heterogeneity, unusual outgassing patterns, and the possibility of seeing structural features that are remnants of the parent body's interior architecture. This is speculative, but not wild speculation. We know planet-scale collisions happen, or moon likely formed from one. We know bodies get disrupted in asteroid belts and scattered across space. An interstellar fragment from such an event reaching our solar system isn't impossible. The difficulty is that natural interior structures from planetary formation processes shouldn't show the geometric regularity some observers claim to see in these images. Planetary interiors have layers, have crystalline structures, have compositional boundaries, but not angular symmetries or proportional regularities. So this explanation handles some anomalies but not others. And then there is the explanation nobody in official channels wants to discuss publicly, but that is being quietly debated in certain corners of the astronomical community. What if 3I Atlas isn't entirely natural? Not claiming it is artificial. That is too definitive. But what if there is a component, even a small component, that involves non-natural processes? This is where Harvard astrophysicist Avi Loeb's work becomes relevant. Loeb has been careful, measured, and scientifically rigorous in his approach to examining unusual interstellar objects. He was the prominent voice suggesting Oumuamua, the first detected interstellar object, might warrant consideration of non-natural origins based on its acceleration characteristics. He was also careful to state that natural explanations remained most likely. But that scientific integrity required seriously examining all possibilities that fit the data. With 3I Atlas, Loeb hasn't made dramatic public statements, but in technical discussions and papers, he has noted that the object's characteristics merit careful observation. His position, and this is important context, is that most unusual space objects are natural, that we should expect natural explanations to prevail, but that when you encounter something genuinely anomalous, when conventional explanations require increasingly elaborate assumptions to fit observations, scientific honesty demands considering less conventional possibilities, not embracing them, not promoting them, simply not dismissing them reflexively. Here is what that careful consideration looks like for 3I Atlas. If the enhanced images showing structural regularities are accurate, if those features represent real physical characteristics, you have to ask what natural processes could create geometric patterns. Crystalline structures can create some regularity. Fracture patterns along stress lines can create linear features. Layered material composition can create boundaries that appear artificial. You exhaust those explanations first. But if those explanations require assuming very specific, very unusual compositions and formation processes that we have no independent evidence for, you are fitting theory to observation rather than observation confirming theory. At that point, intellectual honesty requires at least asking whether non-natural processes could account for what is being observed more simply than increasingly elaborate natural explanations. I want to be absolutely clear. This is not saying 3I Atlas is artificial. This is saying that scientific investigation requires examining hypotheses based on how well they explain observations and remaining open to revising frameworks when observations persistently don't fit existing ones. Every scientist I've referenced who discusses this approach emphasizes natural origins as most probable. What they're arguing against is refusing to examine data seriously because it might lead to unconventional conclusions. That refusal isn't science, it is dogmatism. And here is where the implications become genuinely significant. Regardless of which explanation is correct, if 3I Atlas is entirely natural but genuinely unusual in ways that challenge current cometary physics models, then studying it intensively should be a priority. This is an opportunity to refine our understanding, to discover new behavior patterns, to expand our models of what comets can be. If it is a fragment of a disrupted world, that is extraordinary in its own right. It would give us a sample of another stellar system's planetary formation processes, literally a piece of a planet from another star system passing close enough to study. If it contains any non-natural components, even partial ones, even ancient ones, the implications for our understanding of our place in the universe shift fundamentally. But none of those implications can be explored if the response to unusual observations is silence. If images circulating online that show unexpected features are ignored rather than investigated, if legitimate questions raised by credible observers are dismissed rather than addressed, and that is what is actually happening. Not vigorous scientific debate in public forums, not institutional research programs examining the anomalies, not transparent investigation and reporting of findings, just silence. Official statements that present 3I Atlas as routine and unremarkable, while technical literature documents unusual characteristics that aren't routine at all. Why might that silence exist? Maybe it is caution, not wanting to make premature statements about data that is still being analyzed. Maybe it is institutional conservatism, reluctance to discuss anything that might be misinterpreted as suggesting non-natural origins. Maybe it is resource limitation. Major observatories are busy with planned research programs and don't want to divert resources to investigate claims from online forums. Maybe it is legitimate uncertainty. Scientists aren't sure what the anomalies mean yet and don't want to add confusion by discussing inconclusive findings. All of those are reasonable possible explanations for the silence, but they're explanations that assume good faith and institutional competence. There is another possibility. What if official sources aren't sure how to discuss what they're observing? What if internal discussions are contentious with different experts interpreting data differently, and no consensus has emerged that is safe to communicate publicly? What if someone somewhere in these institutions has seen these leaked images or similar ones from official sources and genuinely doesn't know how to explain what they show? That kind of uncertainty, genuine scientific uncertainty about something observable and immediate, that is the kind of situation that produces not cautious, careful statements but complete communication shut down while internal debates happen privately. I don't know which of these explanations is correct. What I know is this. An observable interstellar object is making its closest approach to Earth this month. Multiple anomalies have been scientifically documented. Images are circulating that claim to show unexpected features. Technical communities are debating those images seriously, and official sources are saying nothing at all. That pattern, that specific combination of circumstances is itself extraordinary, regardless of what ultimately explains it. Here is what makes this immediate. Here is why this isn't academic discussion about data we'll analyze for years. Right now, November 2025, we're in the observation window. The time when 3I Atlas is close enough, visible enough, positioned correctly enough for detailed study, and that window is closing. Not in years, not in months, in weeks. On November 11th, 6 days from now, 3I Atlas reappears in the pre-dawn sky. For observers in the northern hemisphere with clear eastern horizons, it becomes visible again after the period when it was too close to the sun's position for effective observation. This is when amateur astronomers with serious equipment can start capturing their own images, when independent observers can point their telescopes at the coordinates and document what they see. When the conversation moves from debating circulating images to collecting fresh data, December 19th is closest approach. At that point, 3I Atlas will be 60.3 million kilometers from Earth, roughly 0.4 astronomical units. That is close on cosmic scales. Not dramatically close. We're not in any danger. There is no collision scenario, but close enough that telescopes with decent aperture can capture meaningful detail. Close enough that spectral analysis can detect compositional characteristics. Close enough that if there is anything genuinely unusual to see, this is the window to see it. And then it leaves. 3I Atlas continues on its hyperbolic trajectory out of our solar system. By late December, it will have moved far enough away that detailed observation becomes progressively more difficult. The object dims as it recedes. Angular size decreases. The coma may dissipate as it moves away from solar radiation intensity that drives out gassing. The window for high-quality observation is essentially November through mid-December 2025. 2 months and then it is gone, likely forever back into interstellar space, where we can't follow it or study it further. This creates genuine urgency for anyone interested in this mystery. If you want to know what 3I Atlas actually looks like, if you want to verify or refute the claims being made about structural features, if you want to contribute to understanding what is real and what is interpretation, you have 6 weeks. That is it. After that, you are working with whatever data was collected during this window, debating images that were captured during these weeks, forever unable to gather new observations to resolve disputes. Let me tell you what is required to observe 3I Atlas yourself, because this matters for evaluating claims. You need a telescope with at least an 8-inch aperture, that is about 200 millimeters. Larger is better. 10-inch or more gives you significantly more light-gathering capability. You need a decent mount because you'll be tracking something moving against the star background. You need a camera capable of long exposures. Even a good DSLR can work if you know what you are doing, and you need clear dark skies. Light pollution matters enormously for detecting faint objects. With that equipment, 3I Atlas should appear as a faint smudge. Magnitude around 10.5, visible but not bright. You won't see it with naked eyes. It is too dim for that. Through a telescope, without processing, it'll look like a fuzzy spot, maybe with a hint of a tail if conditions are good, but that is where image processing comes in. Modern astrophotography techniques can stack multiple exposures, subtract background noise, enhance contrast, and bring out details invisible to the naked eye, even through good telescopes. That is what creates the enhanced images circulating online, and that is what you can do yourself if you have the equipment and skills. This means the claims circulating about 3I Atlas are verifiable by independent observers. You don't have to trust NASA. You don't have to trust leaked images of uncertain origin. You can point your own equipment at the object and see what you capture. If structural features are visible in properly processed imagery, other observers should be able to see them too. If the features claimed in the leaked images are real, they should appear in independent observations from different locations using different equipment. That is how science works. Independent verification, reproducible observations. And that is exactly what is starting to happen. In the past 48 hours, as those leaked images have circulated more widely, amateur astronomers with capable equipment have been posting their own observation attempts. Some are saying they see nothing unusual, just a faint fuzzy comet-like object, exactly what you'd expect. Others are saying they see anomalies, structural hints, features that seem odd, but they're not sure how to interpret. The data is being crowdsourced in real time by a distributed network of independent observers. This is actually extraordinarily powerful if it continues. You create a situation where no single authority controls the narrative, where multiple independent sources collect data that can be compared and analyzed collectively, where anomalies that appear consistently across independent observations gain credibility, while claims that don't reproduce get filtered out. This is open source science in action, collaborative investigation that doesn't depend on institutional approval or mainstream media attention, but it requires participation. If only a handful of observers are capturing images, you can't distinguish pattern from coincidence. If dozens or hundreds of amateur astronomers with various equipment levels are all documenting what they see, submitting images with full metadata about capture conditions and openly sharing data for communal analysis, then you have a robust data set that can answer questions definitively. This is why I'm emphasizing the observation window. This is your opportunity to contribute real data to this investigation rather than debating other people's claims. Here is what to look for if you observe 3I Atlas yourself. First, general appearance. Does it look like a standard comet with fuzzy coma and developing tail? Or does it have unusual visual characteristics? Document brightness relative to nearby stars. This helps track whether it is brightening or dimming as predicted. Capture multiple images over several nights if possible, watching for changes in position, brightness, or appearance. If you have color imaging capability, document any color characteristics. Is it neutral gray, bluish, reddish? If you are processing images, experiment with enhancement techniques, but document what processing you applied. Unprocessed raw images matter, moderately processed images matter, heavily enhanced images matter, but knowing which is which matters most. When people post processed images claiming to show features, the question is always, are those features in the source data or artifacts of the processing? You answer that by showing the progression, raw data, basic processing, aggressive enhancement, so others can evaluate where features appear in that workflow. Pay particular attention to any features that appear consistent across multiple nights of observation. If something looks odd in one image but doesn't appear in images from the next night, it is probably an artifact or atmospheric effect. If a feature appears similar across multiple observation sessions, that suggests it is real and stable. This is how you distinguish signal from noise in astronomical observation. Most importantly, share what you find. Post to astronomy forums with full metadata, date, time, location, equipment specs, exposure settings, processing steps. Let others examine your images, invite critique and alternative interpretation. This isn't about proving you are right. It is about contributing to a collective understanding. Maybe you capture images that support unusual structure claims. Maybe your images show completely normal cometary appearance. Either result matters. Either result contributes to resolving what is real and what is interpretation. Amateur astronomers worldwide, including those in Japan, have been encouraging independent observation of 3i Atlas during November with exactly this approach. Collect data, document methodology, share findings, build collective knowledge. The insight is that previous interstellar objects didn't receive this level of distributed observation attention, and the result was that questions remained unresolved because institutional sources didn't prioritize detailed study. With 3i Atlas, there is an opportunity to create a comprehensive observational record through crowdsourced science, but only if people actually participate during the available window. Think about what happens if no one does this. If amateur observers don't collect independent data and institutional observatories continue their silence, we're left with exactly the situation we have now. Leaked images of uncertain provenance, claims we can't verify, debates we can't resolve, questions that persist forever because the observation window closed before anyone gathered the data needed to answer them definitively. That is a failure not of science but of scientific opportunity. We have the tools, the access, the visible object and the time. Barely what we need is participation. By December 15th, the window will have effectively closed. 3i Atlas will be far enough away that detailed observation becomes prohibitively difficult for amateur equipment. Maybe some major observatories will continue tracking it, but that data may not be publicly available for months or years. The opportunity for independent, open source, immediately shared observation ends in about 6 weeks, and then we're back to trusting institutional sources that have so far chosen silence over explanation. Is that acceptable? Is that satisfying? Or do you want real answers based on data you can verify yourself? That is the December question. That is the urgency. This isn't about believing or disbelieving claims. This is about collecting evidence while evidence can still be collected, about answering questions while answers are still accessible, about using this brief moment when an interstellar visitor is close enough to study before it disappears forever into the cosmic dark. The clock is running. The object is visible. The tools exist. What happens next depends on whether anyone actually looks. So, here we are, November 2025, an interstellar object exhibiting documented anomalies that puzzle scientists, images circulating through online communities making specific claims that institutional sources won't address, an observation window open right now that closes in weeks, and questions, fundamental questions about what we're actually seeing and what it means that remain comprehensively unanswered. Let me summarize what we actually know. Stripped of speculation, we know 3i Atlas has exhibited unusual behavior, documented by multiple observatories. Color changes that don't match standard cometary evolution, brightness fluctuations that don't align with predicted patterns, water emission signatures that appear non-uniform, coma development described by credible observers as irregular. These aren't rumors. These are published scientific observations that you can verify by reading the technical literature. The mainstream science establishment isn't denying these characteristics. They're just not emphasizing them in public communications. We know images have appeared online claiming to show structural features visible in enhanced photography of 3i Atlas. We know these images are generating serious technical debate among amateur astronomers and processing experts. We know some observers claim to see geometric regularities while others see artifacts and pareidolia. We know the images remain unverified by major institutions, but also haven't been definitively debunked. They exist in a liminal state of uncertain authenticity that institutional silence perpetuates. We know the observation window is open now and closing soon. We know independent verification is possible for anyone with appropriate equipment and skills. We know that crowdsourced data collection could resolve many of the current disputes if enough observers participate. And we know that after December, this opportunity vanishes as 3i Atlas recedes beyond practical observation range. What don't we know? We don't know definitively whether the structural features claimed in circulating images are real or artifacts. We don't know whether the accumulated anomalies represent unusual but natural behavior or something more fundamentally anomalous. We don't know why institutional sources have chosen complete silence over clarification, debunking, or investigation. We don't know what data those institutions have collected that isn't being publicly shared. We don't know what internal discussions might be happening about observations that aren't making it into official communications. Most importantly, we don't know what we'll find if we look, if independent observers capture comprehensive imagery over the next 6 weeks. If that data gets analyzed collectively and transparently, if questions get asked and pursued seriously rather than dismissed reflexively, we don't know what that investigation might reveal because it hasn't happened yet. The observation is still ongoing, the data is still being collected, the story is still unfolding in real time, and that is what makes this moment extraordinary. You are not watching historical analysis of something that happened long ago. You are not debating decades-old data through layers of interpretation and institutional filtering. You are experiencing the observation window itself, the time when the object is visible, when questions can be investigated, when evidence can be gathered that settles disputes rather than perpetuating them. How often does that happen? How often do you get to participate in real-time investigation of something genuinely mysterious? Here is what I need from you. If you made it this far, you are clearly the type who questions, investigates deeper than surface narratives. You are not satisfied with official sources say it is routine when the technical literature documents anomalies. You are not comfortable with those images are probably fake when no one with authority has actually analyzed them publicly. You want answers based on evidence, not dismissal based on assumptions. So, hit that like button. Not because I am asking for engagement metrics, but because this investigation deserves visibility. The algorithm determines what gets seen. What gets seen determines what gets investigated. What gets investigated determines what we learn. Your engagement is literally part of determining whether this story gets pursued or buried. If you think these questions matter, if you think the observation opportunity should be maximized, if you think silence from official sources is itself significant, then engage. Make this visible to others who might care. Make this conversation large enough that it can't be ignored. Drop a comment. Tell me, have you observed 3i Atlas? What equipment do you have access to? Do these claims about structural features seem plausible to you or obviously mistaken? Where are you watching from? Your observation matters. Your perspective matters. Your data, if you collect it, matters. This is distributed investigation. The value increases exponentially with participation. One person with a telescope capturing images is an anecdote. 50 people across different locations with various equipment, all documenting what they see as a dataset. A dataset can answer questions definitively in ways individual observations cannot. Subscribe and turn on notifications because this story continues. I'll be tracking what independent observers report over the next 6 weeks. When December 19th closest approach happens, when December observations accumulate, when patterns emerge from crowdsourced data, I'll be analyzing what we're learning and what it means. You'll see that analysis here before mainstream coverage decides whether to acknowledge this story exists. You'll be part of the discovery process rather than a passive consumer of pre-filtered information months later. But most importantly, and I mean this, look up. If you have access to decent equipment or know someone who does, observe 3i Atlas yourself. November 11th onward, pre-dawn eastern sky, constellation Leo. It is visible. It is observable. You can collect data that contributes to answering these questions. You can verify or refute claims being made. You can be part of determining what is real and what is interpretation. That is not metaphorical participation. It is literal scientific contribution. Your images captured independently compared with others captured elsewhere become part of the evidence base that resolves this mystery. Or don't. You can wait for official sources to eventually release statements that may or may not address the questions being asked. You can trust that institutional science will investigate thoroughly and communicate transparently. You can assume that if anything genuinely unusual was happening, mainstream media would be covering it. That is a valid choice. Passive information consumption is easier than active investigation, but when the observation window closes, When 3i Atlas has moved too far away for detailed study, when the only data available is what was collected during these 6 weeks, you'll know whether you contributed to that dataset or not. You'll know whether you took the opportunity to look when looking was possible. The mystery continues. December will bring new observations, new data, new analyses. By year-end, we'll have a much clearer picture. Either these anomalies and structural claims have independent verification, or they don't. Either the accumulated observations support something genuinely unusual, or they resolve into natural behavior with better data. Either official sources break their silence with explanations, or their continued absence of comment becomes its own statement. But how we get to those answers, how robust the evidence is, how confident we can be in conclusions, that depends on what happens during this observation window. 6 weeks, an interstellar object at its closest approach. Questions that can be answered if anyone actually pursues them, and you right now with a choice to participate or observe passively. The object is above you. The telescopes exist. The processing tools are available. The forums are active. The observation window is open.